Okay, good morning, and welcome to Module 5, Lesson number 4 for 8th grade math. Today we are not starting on the first page because there's a better example as we go. So we're going to start on page 22, and the first thing that we're going to do today is write down some definitions for discrete data and continuous data. Up until now, we've worked with the continuous data, where things are not separate but continual data and it's only numerical. For example, the faucet that we had been talking about in the last lesson, when you turn the faucet on, the water runs continually. It runs not only at 1 minute and 3 minutes and 7 minutes, it runs at 1.5 minutes and at 2.25 minutes. It runs all the way in between there. Today we are going to introduce discrete data, which is defined separate values. It can be numerical or it can be categorical. What we mean by that is, for example, discrete data is like you go to the store and you want to buy some shirts. So you can either buy 1 shirt, 2 shirts, or 3 shirts. You cannot buy 1.5 shirts or 2.25 shirts. You have to buy 1, 2, or 3. They're separate. If you're a band person, it's like having staccato notes rather than a long note. And that's the best way I can describe that. So on page 22, we're actually, for the video, only going to go through exercise 1. We can go through more together at lunch or before school if you still don't understand. So what we want to talk about here is exercise 1 right here, where it says a linear function has the table of values below related to the number of buses needed for a field trip. So it says number of students is 35. If you have 35 students, you need 1 bus. If you have 70 students, you need 2, 105, 3, 144, and it goes on. First it says, write the linear function that represents the number of buses needed y for x number of students. And if you recall from the last lesson, in order to write a linear function, that means we're going to write a linear equation, and we first need to figure out our unit rate. Remember, to find unit rate, we're going to do a y value divided by the x value here. And it doesn't matter which one, you should get the same thing, hence the word linear. So I'm just going to choose the first one. I'm going to do 1 divided by 35. And you can leave it as a fraction there, or you can make it a decimal of 0.028. So my linear function, we're going to use the general form y equals mx plus b here, where m is my rate and b is my starting amount. So this one's going to be y equals my rate. My unit rate is 0.028 plus, oops, I'm sorry, I forgot my x there. X plus b is my starting amount. If I take 0 students on a trip, my starting amount would be 0 buses in this case. Okay, now b, describe the limitations of x and y. So in this lesson, I really like it because it forces you to not only use the math, but to use your brain to think about scenarios where the math fails you. So the limitations of x and y. Let's first think about what numbers we can't have that are obvious. So x stands for number of students, and we can't have a negative number of students, nor can we have a negative number of buses. So negative numbers do not work. Also, there's other types of numbers that won't work here as well. And if you think about it, students come in whole numbers as well as buses. You can't have half of a student or half of a bus. So negative numbers and also fractions or decimals do not work either for this case because they are not right for the situation at hand. So that's where you have to think with your brain as well. And we're going to move on with this idea here in the next question. So if you turn the page to page 23, we're going to keep going with this. So part C now asks you, is the function discrete or continuous? And remember, discrete means you have separate individual pieces of data. It's not a continual thing. Well, in this case, it is discrete again. Again, because you can't have half of a student, you can't have half of a bus here. And you, like, you know, if 35 students come, you need one bus. You can't have a half in there. Okay, so let's get to the meat and potatoes here. The entire 8th grade student body of 321 students is going on a field trip. What number of buses does our function assign to 321 students? So if you take this was our function, y equals 0.28x. It really said plus 0 as well, but I'm going to leave that off because we know that plus 0 is not quite necessary on there at this point. So 321 students, is that an x value or a y value is what you have to ask yourself. So if you look back at the original chart, it will show that students is our x value. So if you plug that in for x, okay, and so 0.028 times 321, you get y equals 8.988, which is not our final answer. I can't call the bus garage or the Department of Transportation and say, I have 321 students going on this field trip. I need 8.988 buses, please. They're going to say, okay. Do you mean 9? Yeah, we mean 9. We can't have a partial bus. So our answer then should not be 8.988. It should be 9 buses is what we need. Okay? So now E asks you to do it again. It says some 7th grade students are going on their own field trip to a different destination, but just 180 are attending. What number does the function assign to 180? How many buses are needed for this trip? So again, you're going to use the same method you did in part D here, only we're going to change our number of students to 180. So if you plug that in, y equals 0.028 times 180, okay? If you do that in your calculator, you get y equals 5.04. Okay, that's not the answer. Again, you cannot call the bus garage and say you need 5.04 buses. You have to tell them, do you need 5 buses or do you need 6 buses? So some of you want to round that. You say, oh, that's closer to 5, so I need 5 buses. Well, technically that's incorrect. We are going to need 6 buses because if we don't get 6, this 4% of students is not even going to be able to attend, or we're going to be overcrowded on the bus. Not too overcrowded, but enough. So our answer then, we have to round up in this case. So we're going to say we need 6 buses. And it probably could be argued in this case that you could do 5 buses and assume that 4% of students are going to be absent that day, or you can put the skinny kid in the middle and have a 3-person seat, or someone's in trouble or so on. So 4% is not really that much. Okay, so F now. Again, same thing. What number does the function assign to 50? So let's do it one more time. Y equals 0.028 times 50. Okay, so if 50 kids go on the field trip, how many buses are we going to need? If you type that in, you get y equals 1.4. Okay, now, do we need 1 bus or 2 buses here? Again, 1.4 rounds to 1 if you round correctly. However, we are going to need 2 buses because otherwise this 0.4 of the students that are left, which is 40% of the students, are going to get left behind. And that one, you can't really fudge it all. At least the one up here, if you had 4% of students to account for, they might be absent. You might be able to get away with 5 buses in this scenario. In this scenario, you have 40% more students here. and there's no way that you're going to get away with just one bus and be legal. Okay, so that is it for our lesson for today. There are more examples that you can get from a friend or from me later. The homework is going to be on page 26. There's questions that are very similar here. We're going to start on page 26 and do the problem set, so numbers 1 through 4. Again, if you have questions, please see me either before school or at lunch, and I will be glad to help you out.